Hi guys, welcome again. Okay, so we're continuing with question 2.2. Just getting my screen right. We're continuing with question 2.2. It says, determine the values of x in the interval x is between minus 180 degrees and 180 degrees for which A, both graphs are increasing, B, f of x plus 10 degrees is greater than g in x plus 10 degrees. Okay, let's start with A. When a graph is increasing, or both graphs are increasing, we are looking at a space where the gradient of the graphs is positive, or it's greater than 0. If I look at the graph of f, I can clearly see that from this point C, which we said is minus 150 degrees, the graph starts increasing all the way to point D, which we see is 30 degrees. Okay. But when I look at the graph of G, the graph of G starts increasing at this point here. This point here, what will be this point here? Well, the graph of G, remember it's the 2 sine x. So it's twice the normal sine curve. So which means this is 90 degrees and this should be minus 90 degrees. Because the normal sine curve peaks positive, there's a positive peak at 90 and a negative peak at minus 90. Okay? Those are the first peaking points. Now this one is just 2 times that. So this is still 90, that will still be negative 90. But if you focus again on the graph of G, you discover that the gradient starts being positive right here, right, at minus 90. So we can clearly see that at minus 90, both graphs are now beginning to have a positive gradient. So for 2.2a, we can see that the first point is going to be minus 90 degrees. Okay, then the other point where both of the graphs have a positive gradient is this point here, D. Because if you see what happens at point D, the graph of f begins to have a negative gradient there. Okay, so which means the other point is 30 degrees. Okay, so that's it for 2.2a. B says f of x plus 10 is greater than g of x plus 10 degrees. Now, both graphs, you can see that this f of x plus 10 and g of x plus 10, they have been shifted along the horizontal axis the same manner. Okay, you remember that a shift of positive 10 degrees actually means the graph goes backwards. So both graphs go backwards. Okay, so what if we first found out where f of x is greater than g of x without the shift? Can we figure that out? I think we can. If we look at this, you can see that from the point C onwards, the graph of f goes up and the graph of g goes down. So from point C, the graph of f is greater than the graph of g, right up until we reach point D, where the graph of g now begins to go higher than the graph of x. Remember, when we want to see which function is greater than the other, we're basically looking at when the y values of that particular function are greater than the y values of the other function. So from minus 150, the y values of f are actually greater than the y values of g. Okay, so the first thing we can see is that, oh, this happens at minus 150 degrees all the way to 30 degrees. So f of x is greater than g of x within this range here. But now we are shifting the graphs by 10 degrees. So in other words, both graphs move back by 10 degrees. So we can now clearly see that, oh, the values of x, where f of x plus 10 is greater than g of x plus 10, we're going to move back by 10 degrees. This becomes minus 160. Move back by 10 degrees. This becomes 20 degrees. So our correct answer should be minus 160 degrees less than x less than 20 degrees. Okay, my x there looks a little weird, but that's a bad x. So minus 160 degrees less than x less than 20 degrees. So this is the range where f of x plus 10 is greater than g of x plus 10 degrees. Okay, 2.2.3 says determine the range of y equals 2 to the power of 2 sine x plus 3. So what we'll need to do to determine the range is, obviously we can see that the 2 sine x plus 3 is what's going to affect this function. Now to understand the range of 2 sine x plus 3, let's think of a normal sine graph, sine x. Okay, a normal sine graph will have a maximum value of what? Of 1, a minimum value of minus 1. What if we now say 2 sine x? In other words, we're multiplying everything by 2. What is the maximum value now? Well, the maximum value becomes 1 times 2, and there we multiply by 2. The maximum value becomes 2. The minimum value becomes minus 2. Okay. But still we need to add another transformation, add 3. So now 2 sine x plus 3, the maximum value will be what? We're going to say to the 2, add 3. To the minus 2, also add 3. So the maximum value is 2 plus 3 is 5. The minimum value is minus 2 plus 3 is 1. So this graph will, if I have a function of y equals 2 sine x plus 3, the minimum value will be 1, the maximum value will be 5. Okay. So when it now comes to this particular function, I'm going to say, well, the minimum value is going to be when it now comes to this particular function, I'm going to see that, well, the minimum value is going to be 2 to the power 1, and the maximum value is going to be 2 to the power of 5. So now I can see that, oh, okay. So the range of this function is actually 2 and 32. Okay. So how did I do that? I just first looked at the normal sine graph. I found out the maximum and the minimum value. Did the first transformation. I focused on the 2 multiplied by 2. So the new range was now 2 and minus 2. Then I focused on the next transformation, add 3. Add 3 to the 2 becomes 5. Minus 2 plus 3 becomes 1. So now the new minimum value is 2 to the power 1. Now maximum value is 2 to the power 5 of this function. So the range will be 2.